In this segment, we're going to talk about extractive summarization methods from a different perspective, which is systems using neural networks for the single document summarization case. And so I'll kind of give a sketch of what most of these techniques look like by referring to this figure from Nalapati et al., where what they show here is basically a model that encodes each sentence and does some kind of pooling over those to produce a document representation. And then that document representation is sort of fed back into or combined with each sentence, let's say, to try to predict whether or not that sentence should be in the summary. So this is a relatively straightforward, almost like a sentence tagging problem, right? Where we want to tag each sentence as either 0 or 1, or classify it as 0 or 1. The one kind of caveat here is that if we know we want it exactly 3 or 4 sentences, we need to do something a little bit extra here, like for example, take the scores of all of these classification decisions, rank them, and take the top 4 or something like that. And don't really use it as a classifier per se, but instead just use it as a scoring function. So this is the basic template that a lot of these systems fall into, and so I'm not going to talk about the whole breadth of systems here. Instead, I'm going to talk about a recent one due to Yang Liu et al. From 2019, not 2017 like it says, which is based on BERT. And so what he did in this work was take BERT or take the document and feed it into BERT and use that to produce a representation for each sentence. And this is by having a CLS token appear at the beginning of each sentence and grabbing those representations as the aggregated representation for that sentence. Then each of these sentence representations is fed into what's called a summarization layer that then produces decisions about what the summary should be. Okay, so what are these summarization layers? So they experimented with 3 of them, a classifier, a transformer, and an LSTM. This is to kind of combine information across multiple sentences and reconcile these decisions. And what we can see from these Rouge values here is that it really doesn't matter much what layer you use here. So, I mean, again, the encoder matters a lot, and the general setup of the neural model matters, but the specifics of how you aggregate this stuff is not so important. So the other thing that I want to emphasize here, because this is the first single document case we've looked at, is this baseline at the top, the lead baseline, which is basically take the first few sentences of an article. And so this is news summarization. This is on a data set called CNN Daily Mail of articles from CNN and Daily Mail. And this is a very strong baseline. You can see that its Rouge scores are actually better than, well, okay, it's not better than some of the techniques listed here, but there are plenty of summarization techniques people have proposed which fall short of this baseline. This kind of is indicative of a trend in news summarization or in news writing in general, which is that the first few sentences usually tell you about the sort of main events and main stuff going on in the article. So it can often be very hard to produce a better summary than just taking those first few sentences. Now, obviously, this will not be true in other settings like biomedical articles summarization or legal document summarization. But in the newswire settings that people often work on as kind of standard tasks, this is something that we see. So regardless, the BERT approach is able to do a bit better than this, and this BERT-based extractive system is probably the kind of system you would want to employ if you were doing extractive summarization and you had some supervised data to train on. That's the end of this segment.